Greetings. I get a lot of requests to cover more space-related topics, and even within that, there are two relatively unrelated topics. The pure science side of space, which is astronomy, and then the space industry side, which is companies like SpaceX and other ways that investors can invest in space-related businesses, and workers can even get jobs in space-oriented companies if they find that to be an area they wish to focus their career on. But the astronomy side of space is still dominant because that's where there is a lot of progress in research, and a lot of that research has been enabled by technology. And we've spoken about that in other videos on this channel, such as this video up here, where I examine why telescope power has risen exponentially and how many things are being discovered now that could not have been discovered even 20 or 30 years ago, and how a lot of threats to humanity, such as the threat of asteroid impact and so forth, has been mitigated, which I also discuss in this video up here. But today we're going to run a basic tutorial about exoplanets, or extrasolar planets, and that means planets that orbit other stars, not the sun. Now, for those of you who have no astronomy background, keep in mind that stars are very far apart. The distance between the sun and the nearest star is about 26 million times the diameter of the sun itself, or about 272,000 times the distance between the Earth and the sun. That means that if the sun were a 1 millimeter wide mustard seed, the nearest star would be another small red speck about 26 kilometers away. So exoplanets, extrasolar planets, have only been discovered very recently because of this exponential growth in telescope power that I mentioned. And until the 1990s, there was only speculation about what types of planets might exist around other stars. There was never doubt that planets existed around other stars because any smaller mass object will ultimately orbit the much larger mass object in its vicinity. But a lot of it was speculation, and entire fictional franchises like Star Trek had to assume that planets around stars existed of a certain nature. They had a lot less to go off of. But this is the chart of the cumulative discovery of exoplanets. And ignore the colors for the moment because the colors are merely the method of detection. As you can see, there was almost nothing in the 1990s until the very late 1990s, and it was still headline news that a planet was discovered around another star. Slowly that number began to increase, and now the number is so large, about 4,800, that nobody even checks it anymore because it's assumed that every year you will find dozens of new exoplanets, probably hundreds of them. And it's not even an event that is hard to predict because this curve is exponential as a function of telescope power rising. And as new methods of detection emerge, the types of exoplanets that can be discovered also increase. The red, which is radio velocity, was the only detection method in the early days, but transits and other types of detection methods emerged later and therefore outstripped radio velocity in terms of their efficacy in finding new exoplanets. But it's not just any exoplanets that people are interested in. They're interested in ones that are similar to Earth and also in the life zone of a star. Now, once you apply those two filters, the number of planets falls sharply. Of the 4,800 exoplanets that have been discovered to date, only about 10 or so fit that description. They are in what is the life zone of a star that can even have a life zone and might be rocky, meaning they are Earth-like in size. Now, if a planet in the life zone is a gas giant, meaning it does not have a rocky surface, that is still okay if it has a rocky moon. That is known as an exomoon that lives in the life zone. And there are other considerations as well. If the exomoon is too close to the gas giant planet, then there's too much radiation and so forth. But these are various filters that can be applied. Now keep in mind, exoplanet discovery is often tied with the likelihood of the discovery of extraterrestrial intelligence. And even though exoplanet discovery is rising a lot, I believe extraterrestrial intelligence is far less common than some of the enthusiasts believe because of the accelerating rate of change. And I wrote a very detailed article about this way back in 2009, and I'm going to do a lengthy video about that subject in the future. But there's a good chance that in terms of extraterrestrial intelligence, it's not as common as we think, and we might be at or near the highest stage of development relative to other planets with life, at least in this galaxy. Different galaxies are another matter. But back to exoplanets. This Wikipedia page has a lot of subtopics and a lot of other links to look at. And if you look at discovery characteristics, many exoplanets are still gas giants and otherwise are very close to their stars. And to be Earth-like, you see here the logarithmic scale of size. There's Earth, Neptune, and Jupiter. And the orbital period, Earth is of course 365 days. So that is over here. A whole lot of planets with parameters similar to Earth have not yet been discovered because the instruments are only at the very edge of being able to find planets like that. And the fact that 10 or so have been discovered is very good, and more will follow in the future. But that is still a harder type of detection relative to much larger planets that are much closer to their stars. Now, speaking of stars, what type of stars could have a life zone in the first place? For that, we go to this website, Sol Station, which has not been updated in many years. I think the main entries on this website were in the 2008 to 2010 timeframe. If there's a better website for this purpose, please let me know in the comments below. But here's the thing. In a 20 light year radius of the sun, stars within 20 light years, about 15% are the types of stars that could have a life zone around them under a conservative definition, and those are the stars categorized as G or K. Stars higher than that are too bright and also have too short of a lifespan, and stars lower than that probably have too much density and too little light and therefore have certain limitations, although I'll talk about what could help get around those limitations and increase the number of stars that have life zones. But for now, assume G and K type stars are the ones that could have a life zone. G, of course, is the category that contains the sun. Now, within a 20 light year radius, there are 150 stars, and of these, 22 are either G or K, so about 15%. And the combined mass of all these objects is about 52 solar masses. But the G and K stars are still 22 in number within a 20 light year radius. And if you scroll down, you can see what these stars are. In the G category, yellow-orange, the sun, known as Sol, is the first one, and there are these others also. And in the orange-red category, the K category, you have these others. So G and K are those 22 stars that I mentioned. This is categorized by distance from the sun. But among these M-type stars, which are these red stars over here, the largest among those, meaning those that are close to the K category, the red stars that are almost orange-red, they may have exoplanets that are in a life zone but are tidally locked, meaning the same surface always faces that star, and therefore life is not possible probably on planets around those stars. But if such a planet has an exomoon, the moon is obviously not tidally locked to the red star. Now, there's other concerns with these red stars, such as the great variability in their light and the amount of radiation they emit, and that might preclude a life zone around those stars. But it's possible that the upper extreme of the M category of stars, meaning the M stars that are almost in the K category, not far from it, are ones that could also have a life zone, at least a life zone for exomoons, not exoplanets. And therefore, the percentage of stars that could have a life zone rises from 15% to maybe 20 to 25%. But then make your own preference about what filter to apply, whether 15% of stars are one that could have a life zone or it's as high as 20 to 25%. And of course, we're assuming all life has to be similar to the life we are familiar with on Earth. There could be very different types of life as well, but for the moment, we're assuming that conditions that are at least somewhat similar to ones that we experience on Earth are the ones under which life can form, because we have simply not had the privilege of observing an example to the contrary. So this will tell you about what stars actually exist in the vicinity, and if 15% of stars are in the life zone and the Milky Way has 200 billion stars or whatever, you can do the math about that. That means 30 billion are of the G and K category, and even if you exclude the ones that are too close to the center of the galaxy, no matter what, there's still billions, maybe even over 10 billion stars that have a life zone, even under these most stringent filters. And exoplanets are common, as we have found. We have enough data to be able to project how many exoplanets there are in the galaxy. And going back to the Wikipedia article, it does say up top that about 1 in 5 sun-like stars have an Earth-sized planet in the habitable zone. And it can be hypothesized that there are 11 billion potentially habitable Earth-sized planets in the Milky Way, rising to 40 billion if planets orbiting numerous red dwarfs are included. So if you're interested in looking at this counter, you may want to bookmark this particular Wikipedia page, which will be in the description box below, and keep checking back this number every month or so. Right now it's 4,801. It keeps rising. And as it keeps rising, the number of smaller planets being discovered increases as well because of the precision of telescopic power that is increasing. Also, the missions that are launched in space to detect these exoplanets are also increasing in number simply because the cost of a certain power of telescope is going down. As you scroll down the Wikipedia page, there is other information you may be interested in. especially in this See Also category, which talks about exomoons, list of exoplanets, exoplanets extremes, list of exoplanet search projects, and so forth. So this is a great place to get started. There's still not a huge amount of subject matter in this field, but the fact that there's any at all, when, as I described earlier, in the year 2000 there was almost nothing to look up in terms of exoplanets. In fact, there wasn't a Wikipedia to look up either that had any information of value. So now you have all this information at your fingertips through the wonders of technology, both internet technology as well as the computational technology that makes telescopic power rise. And if you're enthusiastic about this subject, you can keep checking back and see the new updates and research releases that occur. So this was a video about the pure science side of astronomy, not the business side of space, the space sector, which we talk about in other videos on this channel. But I hope you found this inspiring and informative, and if you like this type of content, I encourage you to subscribe to this channel. Thank you very much for watching.